Envisage your sustainable modular lunar settlement, capable of supporting 400 occupants, identifying and researching accessible natural resources, and providing a base for further long-range expeditions so that we can start here and go anywhere. Welcome, everyone. We are Magellan Space Enterprises, and let us introduce you to A Victorial. This is John Hatfield, and he's going to overview the base.
So your settlement is designed around a unique modular structure capable of expanding to your requirements. So it is supported by a fully integrated and cost-effective safety feature to ensure ultimate safety for your employees, partners, and stakeholders. Your researchers will have access to state-of-the-art laboratories situated directly on the lunar surface. Your crews also have access to first-class living quarters, community spaces, and clinical facilities. Innovative automation and operational systems ensure all potential hazards are mitigated and high-risk activities are performed only by unmanned machinery. Due to the extensive experience of our team, our commitment to your settlement and comprehensive planning, the first stage of your settlement will be habitable and self-sufficient within 4 years. So shown are the 5 research, development and construction sections you'll see throughout this pitch. So the commercial section covers the business and costing aspects of the project. The operations and infrastructure section covers the delivery and distribution of consumables, water, food and power production for your workers. The structural design covers the main internal and external structures supporting the foundations of your settlement. The human factors sector looks at the needs of your employees and their physical and mental well-being. And finally, the automation design sector covers the control systems and automated construction vehicles, which make life safer for your workers on the moon. I'll now pass on to structure.
Perfect. Construction, the literal foundation of every settlement. Here at Magellan, we pride ourselves on having the highest standard of work and thus the highest standard of outcomes. We have taken advantage of only the best materials and only the best technologies, which combined with the innovative mindset harboured and bred at our company has resulted in a remarkable, modular, aesthetically pleasing but mostly functional settlement. The settlement is broken up into 4 equally sized quarters, each made up of different modules. These modules include a residential, entertainment, communal, research and clinical building. We've taken a modular approach as it makes for easy expansion and easy replication in other areas of our lunar environment. I'm very sorry I'm having technical issues, which we ensure you will not experience on A Victorial. It is worth noting that the casks will go into the making of the modules. Each module is essentially a cask. I will get straight into the construction sequence then. The construction sequence begins with a 2-year planning phase, after which a 2-year construction stage will start. And in this stage, a construction team made up of 25 people will journey to the moon to begin work. Their initial building work will result in the drilling of the first elevator shaft and the construction of half the solar farm. After this vital stage, it can be habituated by its first lot of people other than the construction team. Now, it is worth noting also that the first occupants there after the initial stage will take up about 25% of the permanent research and residential staff and population of A Victorial's settlement. At the end of phase 2, the solar farm will be complete and the settlement will have capacity for research, as the labs will also be built. Now, the third phase will focus on the converting of the first landing pod into an observation deck, which is another interesting point, that the landing pod, which we are conceptualizing, will take the casks up and then once it's landed and the second phase is complete and we're on to the third, it will be converted into an observation deck under which a third or second, I believe, elevator shaft will be drilled. This will be completed, and as a result, the first segment will be fully operational. That is going back to it being separated into quarters. The first quarter will be completely finished. The fourth phase will almost identically mimic the last, with the exception of it being in a new area, obviously, and that more people will be able to come in because we will now have 3 quarters finished. And finally, after 10 years of planning and construction, Phase 5 will be completed. And A Victoria will be fully self-sufficient and ready for full habitation. Now, to make our construction phase the absolute most efficient and easy it can be, we are utilising the abilities of the F1 M8. I'm extremely sorry about this. The F1 M8 welding robot and a conceptual and groundbreaking cask repurposing robot. This robot will be used to move casks and turn them into new creations, i.e. the modules that will make up our quarters. We also have conceptualised a fleet of utility bots which will help, here they are, which will help manage the running of our settlement. Now, each of the 4 sections has their own respective elevator shaft, which takes you directly to the lunar surface, where you will be dropped off in a hub. Here they are, you can see the 4 going across there, from which you can travel to, as I mentioned before, the observation deck, which is a repurposed spacecraft. And the observation deck's main role is to connect the residents of A Victoria with their outer environment. It is essentially to upkeep morale. It's also, of course, assumedly extremely interesting. From these hubs that you get dropped off at from the elevator, you can also walk through a tunnel to the research facilities and the research labs where you have direct access to the moon's surface, so you can geologically study it. They also have windows which are reinforced to protect from radiation, so you can see directly outside. Now I'll talk about the materials being used. There we are. Here are some quick dimensions. It'll be about 790 metres long. We will have utilised many different materials in the building of the settlement. Lunacrete, a concrete made from lunar dust combined with the base isolators, will equip A Victoria against moonquakes, while we'll be using super adobe and a polymer aerogel that have been used in the prevention of radiation. Sorry about the technical difficulties. I'll pass on to our human resources.
Here at Magellan, we create not just a workplace, but an exciting and inclusive environment, like a community to grow and prosper. The air on A Victoria matches the composition of gases in the air on Earth. Air composition will be regulated by stored gas and gas exchange from hydroponic farms. Indoor temperature is 23 degrees and is maintained by air conditioning. Any excess hot air that will be accumulated from occupants' rooms and workspaces will be used to keep hydroponics humid in a warm, humid environment to maximise growth. Recyclable waste will be manufactured into new products, and biomass will be turned into hydrogen and ethanol through fermentation. Any excess waste products will be buried. An individual is allocated 14 litres of water consumed per day. Including contingency, this will mean a total of around 10,000 litres of water a day overall.
A Victoria provides occupants a comfortable, authentically pleasing, physiologically healthy settlement for them to reside, work, play, and more importantly, thrive. The community layout and room design have taken into account the needs of humans to ensure all physiological needs are met. The inability to see the outside world has been linked with both depression and feeling of tensions, especially in a work environment. To combat this, virtual windows in occupants' rooms and workspaces will be provided throughout. These have been based on the virtual windows first used by Emirates in their first-class passengers, first designed in 2017. Each occupant's room will also contain a queen bed along with a desk and ample storage. The room will have direct access to a private ensuite with all the basic necessities.
Facilities at A Victoria include a state-of-the-art gym, agricultural land, laboratories, a safe space for religious and cultural use, separate health clinics for each housing modules, and a large hospital to combat and treat larger medical issues. A community hall/recreation space is included in A Victorial's design. It will provide the chance for socialisation among occupants, which is critical to their mental and physical well-being. This will also boost endorphins, dopamine, and serotonin. To balance comfort and efficiency on board, parks and large open recreational spaces are provided. These features are all major parts of the world's most livable cities and have been provided on board because they are associated with better perceived general health, reduced stress levels, and reduced levels of depression, which is essential for a good settlement. We will now be moving on to the operations.
In order to mitigate the highly abrasive properties of the lunar dust, all of our exterior functions, our spacesuits and robots that are in the outside environment, will be fitted with an electrostatic appliance which prevents the dust from ever coming into contact with our external appliances. The modular design of the base enables easy maintenance and repair by F1 M8 robots. Microbial sanitation using UV light and high temperature, a component of the fire response system, and distribution and resupply tasks are performed by multi-use robots. The control centre acts as a main communications point both for high-speed Earth-lunar transmissions and long-range exploration vehicles. We will use wrist tags that have biometric and radio frequency identification to access different parts and facilities within the base. These will be tagged to each person specifically and will enable them to access things that are relevant to their status within the base. Solar energy is used as our primary power supply throughout the base. We have a large array of solar panels, 4,600 square metres to be exact. These are high-efficiency solar panels that will provide all of the necessary energy to power our moon base. The ports, there are 2 of them to supply all of the casks to our moon base, each have a landing dock. These ports will be the primary movement of casks and exports in and out of our lunar base. The internal and external communication system is run predominantly through the control centre. The internals is using the wrist tags, and the externals is the long-range communication systems built into the control centre. A seamless transfer system to deliver casks to a centralised distribution hub where unloaded casks are then welded together to form modules using autonomous Cassack manipulation vehicles, or ACMVs. Once assembled, modules' interiors are prepared by multi-purpose micro-abacus-driven F1 M8 robots, which seal and insulate modules using expanding foam. Modules are then pressurised and retrofitted with on-site 3D printed furniture to suit their use. The lunar base also provides an ideal platform for advanced planetary and deep space investigation. Potential research includes lunar surface analysis and planetary material, understanding the effects of deep space radiation and fractional gravity, external monitoring of Earth's climate, a platform for astronomical observations, and heliophysics. The twin state-of-the-art laboratories, one on surface and one in the lava tubes, facilitate all research areas and allow for future development projects.
In order to achieve a modular and functional design, we have pioneered multiple different Cassacks configurations to make up the settlement. These Cassacks form models. They form modules that can move and connect between one another. Think of it like a giant Lego in space, having the ability to change layouts and rearrange at will. The flowchart demonstrates this process. There will be almost 1,400 cassocks delivered at the settlement. This includes a one-time delivery of construction materials and initial supplies for the first 25 workers, and number to be delivered each year of construction. Key risks associated with the design are moonquakes and Clostridium outbreaks. These risks will be mitigated by first building the moonquake prevention systems for each segment, consisting of beams and pillars on both side and bottoms of the bottom faces. In order to mitigate Clostridium outbreaks, precautions will be taken. The facility where the bacteria is stored will be isolated from the settlement in case the bacteria escapes the fermentation silos. In case the bacteria escapes the fermentation silos, quarantine procedures will be taken, and bacteria shall be neutralized by either heat or UV. At Victorial will cost a total of just under 130 billion Australian dollars, and costs may subject to change as phases continue. Ladies and gentlemen, I give you Magellan. Let's start here and we can go anywhere. Thank you.